Hey there. Buckle up because we're about to dive into some seriously wild physics. Quantum gravity, black holes. We might even be talking about overlapping universes today.
Yeah,
You sent this paper in, and wow, it's a real brain bender. But that's what we're here for.
it's dense, that's for sure. The math is very intense, but I think the core ideas are actually surprisingly elegant. This paper is trying to tackle some of the biggest mysteries in cosmology. And you know what? It might just have found a way to connect the dots. Okay, so let's start with, before we even get into all that, like this idea of the holographic principle. Have you ever heard of this?
Oh, yeah.
It's like saying that the universe is a giant movie screen, right?
Yeah. Oh, wait.
And what we experience as 3D reality is just like a projection of information.
That's stored on some 2D surface, like some cosmic blueprint. This paper is exploring that idea, right?
Yeah, exactly. It's like a cosmic blueprint where everything, even gravity, comes from this hidden layer of information. And what's really interesting here is how they're trying to apply this to the quantum world,
Okay.
the world of particles and fields.
Okay, so we've got this mind-blowing concept of the universe as a hologram, right? Where do black holes fit into all of this? And
Yeah.
what's this business about overlapping universes?
So black holes are really fascinating because they push the boundaries of physics, right?
Yeah.
They're regions of space-time where gravity is so strong that nothing, not even light, can escape.
Oh.
And it's because of this extreme nature that they make the perfect testing ground for theories like the holographic principle.
So black holes are like the ultimate cosmic laboratories?
Precisely. And this paper is suggesting that by studying black holes, we might actually unlock some secrets about the fundamental nature of information itself.
Okay.
They're proposing that instead of information being lost forever inside a black hole, maybe it's actually encoded on its surface, kind of like what the holographic principle suggests.
I see. So it's like it's not really gone, it's just stored somewhere else. Okay, I'm starting to see how this all ties together, right? We've got the holographic universe, we've got black holes as these information storage devices, and now you're telling me about overlapping universes.
Yeah.
How do we get there?
So this is where things get really interesting, okay? So the paper explores this idea that, okay, if the universe is holographic right now,
Right.
there might actually be a limit to how much information it can hold.
Oh, like a cosmic hard drive. That's nearing capacity.
Exactly, exactly. And if we start to hit that limit, it could have some really strange consequences. One possibility that they explore is that new universes, each with their own set of physical laws and constants, might actually start to emerge.
Whoa.
It's like the universe has a way of creating more space, more hard drives to store information.
So you're saying these new universes, they wouldn't necessarily be in some distant realm. They could actually be like overlapping with our own.
That's the idea.
Yeah.
It sounds crazy. I know, it sounds like pure science fiction, but they actually lay out a mathematical framework for how this could work. Of course, it's still very theoretical.
Yeah.
But it's a fascinating glimpse into how strange, how truly weird the cosmos might be. And, this idea of a limited information capacity, it's not just some abstract concept. It could actually have real observable consequences, and that's where the paper's focus on neutrinos comes in.
Okay, so back to those like ghostly particles that can travel through like light years of lead. What makes them so important in all of this?
Neutrinos are fascinating. I mean, they're incredibly difficult to detect, and they barely interact with other matter. It's like they're these tiny, solitary travelers just zipping through the cosmos.
Yeah.
But it's precisely because of those unique properties that they might actually hold some clues to the structure of the universe itself.
How so? How so?
Well, the paper suggests that if this holographic principle is true, if there's this limit to how much information the universe can store, it might actually manifest. We might be able to see it in how neutrinos behave, especially at extremely high energies.
What kind of behavior are we talking about?
Okay, so they propose that at these extreme energies, neutrinos, get this, they might actually start to overlap in a sense. Like
Yeah.
it's as if the universe is running out of space to keep them totally separate so their information starts to blend together.
It's like trying to cram too many files onto a hard drive. Then the information starts to get corrupted.
That's a great analogy. And one of the potential consequences of this information compression, I guess you could call it, is that there might actually be a limit to how far these high-energy neutrinos can even travel. They might hit a sort of cosmic wall, this fundamental limit that's imposed by the holographic nature of the universe itself.
That reminds me of that high energy neutrino they detected a few years back, the one that caused all that buzz about like breaking the speed of light.
Exactly. That detection, it turned out to be an instrument error, But at the time, it sparked all this debate about the fundamental laws of physics, you know? And what's fascinating is this paper offers a totally different perspective on that whole event.
Wait, are they suggesting that that neutrino might have actually hit this cosmic wall instead of breaking the speed of light?
That's exactly what they're proposing. So instead of exceeding the speed of light, which would, totally violate Einstein's theory of relativity, these high-energy neutrinos,
Yeah.
they might be running up against this fundamental limit, this cosmic wall,
Yeah.
that's imposed by the holographic nature of the universe.
That's incredible. So by studying these high-energy neutrinos, we could actually test this whole holographic universe idea.
Exactly. It'd be a seriously challenging observation to make.
Yeah.
But if we could detect a pattern in like the distribution and the energies of these neutrinos, particularly like if there was a drop off in their numbers or a weird shift in their energies at a certain distance, that could be a smoking gun for this whole holographic principle thing.
That's pretty mind-blowing. But okay, if the universe can only store a finite amount of information, what happens when it reaches capacity? Does it
hmm
crash like my old computer?
That is a question that has puzzled physicists for decades, and this paper offers a truly radical suggestion. It might be that new universes are born.
Hold on, new universes, as in multiple universes. Are we talking sci-fi stuff here?
I know it sounds crazy. As wild as it sounds, the math seems to suggest it's possible. And the way they explain it is actually quite elegant. They use this concept called quantum mereology.
Okay, now you're just using big words to sound smart. Come on, what in the world is quantum mereology?
Essentially, it's a way of thinking about how parts of a whole can relate to each other, even if those parts seem totally separate or different.
I'm not sure I'm following.
Okay, imagine like two puzzles, right? Each one with its own unique picture.
Right.
They exist independently, right? But what if there were certain pieces that could fit in both puzzles?
Okay.
That's kind of what quantum mereology is getting at. These shared pieces, they represent information that overlaps between systems, even vastly different ones, like maybe different universes.
Okay, so instead of two puzzle pieces, we're talking about entire universes with shared bits of information.
Exactly.
That's a pretty wild concept.
It is, and the paper argues that these shared bits of information could be the key to understanding how new universes might actually emerge. They propose that as our universe approaches its information capacity, these overlaps become more and more likely, and that could potentially lead to the formation of entirely new universes, each with its own set of physical laws and constants.
Okay, wow. This paper is suggesting some really big things, really big. Our universe, and as huge as it is, might just be one of many, and all of them are connected through this web of shared information. It's a lot.
It really is. It would completely change how we see the universe,
Mm.
how it started, how it changes, even how it might end, everything we thought we knew.
Yeah, no kidding. Okay, so before we get too lost in all these other universes, can we pull back for a second? Is any of this actually testable? Can we actually prove any of this?
That's the million-dollar question, right? And it's something the authors do actually bring up in the paper.
Okay.
Directly observing these other universes, these overlapping ones, that might be beyond what we can do right now, technologically speaking. But there's some things we could look for, clues that could tell us if this is actually happening.
Like what kind of clues?
So one really cool idea they have is to study the cosmic microwave background radiation. That really faint afterglow from the Big Bang.
So we'd be looking back at the very beginning of the universe to find evidence of other universes.
Exactly. They think that if these overlapping universes are real, they might have left like an imprint on this radiation, like super faint ripples, stuff that doesn't fit with our normal models of the universe.
Wow, so we'd be looking for the faintest echoes of other universes in the oldest light that exists. Talk about finding a needle in a haystack.
Oh, it would be incredibly hard, no question.
Yeah.
But they think with the new telescopes coming online and the way we're getting better at analyzing data, we might actually be able to pick these signals out.
That would be wild. To actually have proof, well, some kind of proof of other universes. Cosmology would never be the same.
Oh, totally. And it's not just about the cosmic microwave background either. They talk about how high-energy particles, the kind you get from supernovae or gamma-ray bursts,
Yeah.
how those could be affected too.
Oh, really? How so?
So think of these particles like messengers, right? They're coming from these crazy, powerful events.
Oh, okay. Yeah.
And as they travel, they're carrying information about where they came from. Now, if they pass through a region where our universe overlaps with another, their energy, their path, it might change just slightly. If we could study them carefully enough, we might see those changes.
So they're like little postcards from other universes.
Exactly. Of course, we're a long way from actually doing any of this. The paper's clear about that.
Oh.
We need a lot more research. We need better ways to test these ideas. But still,
Yeah, science. Always pushing the limits. So basically what we've learned today is our universe might just be one of many. They're all connected in ways we don't really get yet, but there are ways to find out if it's true. That about sum it up.
you got it. It's amazing how theoretical physics can take us so far, you know? It makes us rethink everything we thought we knew, makes us ask new questions.
Absolutely. Well, I am definitely leaving this deep dive with more questions than answers, but that's a good thing. If I've learned one thing today, it's that the universe is a lot weirder and more wonderful than we can even imagine.
Couldn't agree more. This is really just the beginning. We've got a lot more exploring to do when it comes to the universe and our place in it.